we are in a space where machine learning and AI is huge, right? Now, I don't have enough time to showcase like a Slido. A lot of you might be aware of what Slido is, but I usually always have that in my slides. But my question would have been to you that, like, I would have posted a word cloud and I would have asked you that, hey, like, when you talk about AI in 2023, what are some of the terms that come to your mind? So some of you might have probably guessed large language models, generative AI, BARD, ChatGPT, Palm from Google. So all of these different terms are somewhat probably familiar to all of you at this time and at this point in time. So you might not be completely aware of what these terms mean, but of course today's session is to demystify some of these very common terminologies and like understand that as machine learning practitioners and using a lot of the different open source tooling provided by Google, including TensorFlow, how you can also actually build large language models that we see, for instance, like ChatGPT. Now, of course, there's also this one very striking fact which is released by the GitHub team, and which is over the past 4 to 5 months, we have seen more than 8,000 different open source projects in generative AI and different type of open source large language models that exist today on GitHub, and this number is only going to be increasing. A lot of the different companies that you see that have sprung up in 2023, majority of them are generative AI based startups, and a lot of companies that were traditional tech have also now adopted AI in some or the other form, specifically generative AI, because it's no-brainer to not include generative AI in your product. So that is why we are seeing a huge migration and a huge shift for the entire industry, adopting these practices and using something like OpenAI APIs, or in this case, like since we'll be talking more about GCP, a lot of companies are now using GCP Cloud in order to adapt generative AI. So we'll be looking at some of those examples as well. Of course, a quick intro to what is LLM. In a nutshell, as for someone who might be an absolute beginner, this considered these to be like very specialized models that are typically focused on a lot of large language context. So you are dealing with millions and billions of records of textual data. It could be some PDFs, or it could be large corpus of different type of information, including like probably news articles. So a huge corpus of textual data that can be utilized to do things such as text summarization, be able to build chatbots like ChatGPT. So these are some of the common use cases that we see when we are utilizing large language models. Now, large language models are not something new. They have existed for a very long time. A few of you might have heard about models like BERT, which were actually in fact released in 2018, 2019. And of course, the complexity or the total number of parameters or the architecture of these models has definitely grown in size, or it has become more complex. We are now dealing with a lot of different parameters. You might have heard of Llama 2 having a 7 billion parameter model or 13 billion parameter model. So what this means is that there is a lot of text, a lot of data to deal with, and the number of parameters that you feed into your machine learning model, in this case the large language model, the more it will be able to become more context aware of different types of things. For example, Llama 2 is very capable of being able to automatically do not only things like text summarization for you, but it can also generate code for you. Similarly, Palm 2, which is launched at Google I/O this year, can, very similar to the GPT-4 model, which is by OpenAI, which is closed sourced, can do a lot of different things, including like being able to generate music lyrics, rap lyrics, or even do standard software engineering problems as well. So, of course, these are some of the different open source and the closed source large language models. Some of you might have already heard of these. But of course, the question arises that how do we integrate large language models with TensorFlow? So as I mentioned, that large language models as a concept is not something that's brand new. We have had a lot of different models. In fact, like the original GPT model is almost 4 or 5 years old now. So since then we have had various iterations of the GPT model as well, GPT-2, GPT-3, 3.5 and 4. So a lot of different toolings available within TensorFlow, and specifically within Keras, which is a library that is built on top of TensorFlow, support a lot of pre-built large language models like BERT and GPT-2. And with the help of one of the core libraries, which is Keras NLP, you can actually directly just call these pre-trained models, and these pre-trained large language models, you can fine-tune them as well. And some of you might be wondering, like, what is this term fine-tuning? So just imagine that when you have a very large model, sometimes you might want to ensure that it is working well with your own set of data. So usually it will take some of the other parameters and tweaking those parameters inside of your model to make them much more optimized for your model, right? So with Keras NLP, it becomes very easy. And again, like, I have not a lot of time, but this is like one such example where what we're doing is, and I'll quickly give you an overview of what is happening over here. So we are using the Keras NLP over here. We are just importing all the standard Keras and TensorFlow libraries. I'll just increase the font size. And then what we're doing is we are loading one of the pre-trained GPT-2 models that comes out of the box with Keras NLP. And we are just invoking and initializing our model. Now, as with any standard NLP operation, you would basically take your input text, and that would you would basically convert that into word embeddings, and then you will tokenize those, all that corpus that you have. You will create word embeddings out of it, and then you will have a model that will essentially capture all these embeddings, and you will be able to get some output from it, right? So that's pretty standard, like pretty straightforward when it comes to dealing with NLP-based tasks. Just one second, probably. I'll probably continue. But the idea really is that once you have now imported your model, you will feed it the actual text on, or the text corpus on which you want to train it, and you'll be able to get results. So we're not really changing or reinventing the wheel when we are dealing with large language models. So the same process of taking your input data, pre-processing it, and then just passing it through your input model, in this case GPT-2 model, right, which we will go ahead and use. I'll not again waste a lot of time, but I'll recommend to all of you to check out the Keras NLP and using it for being able to use pre-trained LLMs like either BART or GPT-2. And trust me, like, these are some of the best ways to get started, because these models are not that huge. Because some of the additional models like Llama 2, they can be almost like 15 GB in size, 30 GB in size, and they require a very compute intensive resources. For example, like dedicated GPU memory in order to be able to run them locally. So these are some of the best ways to get started into and get introduced into the entire NLP and the large language concepts. So I'll definitely recommend them. But of course, as I mentioned, right, that all these different models like the BART and they are pretty old at this point in time, right? So if you want to get used to some of the more latest models, especially the cutting edge models from Google itself, so that's where like Palm V2, as I mentioned, was introduced in this year in Google I/O. So a lot of the different latest APIs, including the large language model that's Palm, are right now available on Google Cloud. So of course you can get free cloud credit, but you can access the Palm V2 API and not have to actually worry about even the deployment of your generative applications, because Vertex CI does take care of that for you. And I am probably, I'm guessing that we do have a Vertex CI session as well. It probably might have already happened or is scheduled for later today. So I'll not go too deep into Vertex CI, but it kind of handles a lot of the different MLOps and machine learning deployment for you. Of course, all of us have kind of faced this, and a lot of us might be able to relate. We have heard of hallucination of the ChatGPT, where we are asking it one question at one time, and you cross-question it, and it will just change its answer. Right? We have had this funny, and not really funny. At times, it also becomes very frustrating as well. That we start to curse on the ChatGPT, but of course, there are certain limitations of large language models. And that's what I just want to cover, right? That some of the biggest challenges that we face today with some of these large language models is the fact that the first thing is that they are very huge, and once they have been trained and you're using them in production, they are not aware of the context for the latest information. So of course, the classical example is the ChatGPT free API, or the free version, which has been trained up till 2021. So you ask it any question above 2021, so from 2022 or 2023, it will simply not be able to answer, right? And the other very important thing to consider is, and this is where we'll be now diving a bit more deeper into the internal architecture of LLMs, which is essentially that when we are training these models, the specific terminology that we are using over here is parametric memory. That means whatever input text on which it is being trained, so input data set on which it is being trained, the context will only stay relevant to that text. So if you are asking it any sort of a question that is outside the context on which it has been trained, it will simply fail to answer those questions. So the question arises that, okay, like how do we solve some of these challenges with respect to hallucination that is fairly common today? So that is where I'll introduce a new concept, and this is like very important, right? The entire idea is fairly straightforward, but it is a very, very important and relevant concept in today's time. And in fact, like a lot of the topmost or the latest models, large language models, very effectively use this terminology called retrieval augmented generation. So you can, just to kind of break this down in very simple to understand terms, essentially what we are trying to do is we are trying to overcome the biggest drawback of large language models, which is the fixed memory or the fixed data or the corpus of the data on which it has been originally trained. So in order to make the large language models stay relevant, that is where this concept of the retrieval augmented generation will help us, where there are essentially two components. One is the retrieval based method. This retrieval based method, essentially what it allows you to do is it will refer your large language model to an external data store. So for instance, think about that, okay, you have trained the large language model on all the GitHub repositories until 2022. But that doesn't mean that GitHub has stopped producing new open source repositories, right? Of course, in 2023 alone, we have had probably hundreds and thousands of new GitHub repositories that have been created. So how do we keep our model up to date? So you could use an external data store. In this case, we use vector storage. So I will definitely recommend all of you to learn more about vector storage. We will use something like a vector store where we will keep all the latest information. And now what will happen is that with the help of the augmentation, like the generative model, whenever we make a call to our generative model, in this case our large language model, we'll also send that query and match it with some of the most relevant latest information that we gain from the retrieval method. So over here what you can probably see in this diagram is that we have the retriever, which is in consistent talks with an external knowledge base, right? And we are leveraging this external knowledge base to get further context for the query that the user is asking you, right? And one of the biggest use cases where we actually use this retrieval augmented generation is that sometimes you might have probably seen that you ask certain questions to your GPT model, right, to whatever model, and it will give you some answers, like you're asking it in a very human-like Q&A format, like you're asking it questions. And when it comes to, like, for example, you ask the question that, okay, who is the Prime Minister of India? So the answer would be Narendra Modi, right? Then you ask what is his birthday? Now, sometimes a very simple implementation of the large language model will not be able to get the additional context that you're asking it for. So it will just simply say, I'm sorry, I didn't get your question. But when you see that, yes, it is able to retain some of the prior information and in fact like give you additional information as well, that's where some of this concept of retrieval augmented generation comes in. So here's like one example where this is like one of the applications is called Pieces Copilot, where I'm taking one code block, I'm asking it a question that, okay, explain this code block, and then I'm asking it a further question that optimizes this function. Because it is already aware of the previous context that has been set to it, it will be able to automatically answer that. So this is one of the areas where retrieval augmented generation comes into picture. That means you are giving additional context to your large language models to not only have a historical context of what all conversations have already taken place, but it will also maintain that. And while at the same time, it will have an external data store through which it will be able to get additional context and not just be limited to the existing data on which it was originally trained. So with retrieval augmented generation, it is able to refer to external data stores to make it or to keep the large language models up to date. And the second thing that we achieve from retrieval augmented generation is that the models can have additional context for previous data points or previous history of the models on which it has been run. And of course, like I'm running out of time, so this last couple of minutes, if you want to implement retrieval augmented generation, I'll definitely recommend you to check out one of the blogs by Google AI, so by GCP, where they use Langchain, which is an open source framework for building LLMs. So in this case, we use the Vertex AI, Langchain, and Palm, which is the large language model from Google, to be able to implement the same capability of having historical context to your previous conversations. And this is a very simple code base. Again, I'll kind of skip through this, but essentially what we're doing over here is, if you carefully look at this matching engine index, right? Probably I can point the pointer. So I guess if you look at these two pieces of code bases, which is exposing the matching engine index, so this is what is essentially doing the point of, like, once the user asks a query, it will refer it to an external data store where it will match the query with the most relevant result from the external data store. So your model will not only be able to give you a contextual answer, but it will also give you a more informed and relevant answer based on your current data set as well. So you will leverage that matching engine to find the most relevant data for you, and you will use that inside of your next function, which is the LLM, to generate the response. So the LLM is not just generating a response based on the question that it asks and based on the initial data on which it has been trained, but we are using some external data store to further fine-tune the result of the model to be more relevant. So, I mean, this entire concept of RAG is to make your responses from your large language models more contextual aware and more up to date. So that's one of the main things that we gain from this. But I know I was running out of time and I had to kind of rush through that part. But again, thank you so much. And I'll be over here till the end of the event. So if you want to discuss anything related to LLMs or related to GCP, I'll be more than happy to have conversations with all of you. But thank you so much.